code works with data. Usually, the data is stored in memory. In code, when you section off a tiny piece of memory to store a chunk of data, say something like a name, address, or date, it's called a variable. It's called a variable because as your code runs, what's stored in a variable is meant to vary, meaning that place in memory might start out with nothing, then it might have some text, then later different text, then later nothing again, whatever you need. Using programming terms, when you create a variable in code, we say that you declare a variable. The code to declare a variable has two things: a name, which you make up, and a data type. We talk about data types right after this section. In code, it looks like this, with the data type first, in this case string, then a space, then your made up name, in this case the word task. You assign a value to your variable with an equal sign, like this. After that line of code runs, our task variable will have the value build a robot. If possible, it's preferred to declare and assign in one line, like this. That's preferred because usually when you're reading code, less lines is easier to understand. So back to that string data type. What's a data type? Say someone was working on a task and I asked some questions about that task, and the conversation went like this. When did you start? 79. Okay. Well, is the task finished? Watermelon. What just happened is a data type mismatch. After asking when did you start, I expected a time like 9 a.m. 79 isn't a time. After asking is the task finished, I expected a yes/no answer, not watermelon. You've seen that before. When websites ask for your personal information, you enter text for your name, date for your birthday, numbers for your phone number. If you try to enter the name in the birthdate field, it usually doesn't work. If it does, bad code. Earlier, when we declared the task variable, we said it had a data type of string. In C# and many other languages, the data type for holding regular text is called a string because it's a string of characters. So why have data types? Well, that allows software to understand and help us with the flow of data. It'll tell us if we're doing something wrong, if, for example, we try to put a name into a date variable. It also helps us make changes to code safely. We'll analyze those reasons in full detail when we talk about static versus dynamically typed languages in a future video. Some other examples of data types are datetime, which is obviously for dates and times. Whole numbers are stored in byte, short, int, or long. Numbers with decimals are stored in single, double, or decimal. Bool, short for Boolean, stores true/false. You might be wondering why there's sometimes several data types for the same type of data. Like, why do whole numbers have byte, short, int, and long data types? Isn't one enough? If so, good catch. It has to do with size. Byte has a max value of 255. If you need bigger than that, short has a max value of 32,767. If you need bigger than that, int has a max value closer to 2 billion. If you need bigger still, long has a max value of 9 quintillion, or 9 billion billion. You might now be saying, that doesn't answer the question. If long can store both small and huge numbers, which it can, why not use long every time? It's less confusing. Well, you can do that if you want, but there's two drawbacks. Bigger data types take up more memory in the computer, and bigger data types take longer to process, so they slow down your code a little bit. For tiny amounts of data, it won't be noticeable, but when you're working with a lot of data, those differences really add up. So, the general rule is that good code uses the smallest data type that makes sense. Let's summarize the key points. We hold small pieces of data in a variable. You declare variables. Variables have a data type, and you assign a value to a variable with the equal sign. Now, let's use a variable to solve our task storage problem.